Do your best. Let's get all the information down for the trig identities. You want the angle sum identities, and then try example 1, answer question number 1 on 618. Then we'll go through a few other things together. Okay? Here we go. Topic 5, this is the last topic we'll cover. I doubt we'll do topic 6. That's just the proof of the law of sines, law of cosines, and we talked a bit about that. But angle sum identities. Sine of angle A plus B is equal to sine A cos B plus cos A sine B. And then cos A plus B is equal to cos A cos B minus sine A sine B. Now, as weird as those seem and as tough as those kind of may seem, or maybe they don't seem tough, one of the difficult parts after applying them is just memorizing them. So if you make flashcards and memorize things that way, or if you just read them over multiple times, somehow memorize those prior to Friday. They're on your quiz on Friday. Okay, you've got to have them memorized. I go through and I know that sine has the two. They have two different ones. They have sine and cos together, versus cosine. Co meaning two. That means two of the same thing, or at least for me. Okay, I memorize things in weird ways sometimes, but anyway. Notice that cosine A plus B, you're subtracting in the middle, versus sine where you're adding. It's kind of counterintuitive. When it says find the exact angle or exact value of cosine 105, so this is we use these to help us use our special angles, our special coordinates. You know, this 30, 60, 90, 45, 45, 90. Use those special angles to find angles that aren't so special. Okay, I know that's sad, but you know. So a 105 degree angle, if we can express it in terms of a special angle, then we can find exact values of it. So cosine 105, if we're using 30, 60, 90, or 45, which one of those makes 105? Yeah, 60 and 45. So we can rewrite cosine of 105 is cosine 60 plus 45. Okay? And so since we have that, we can use now this identity. Okay, we say this is angle A now, and this is angle B. So we have the cosine of A, which is 60, times cos B, minus sine A, minus sine B, or times sine B. Okay. And then we continue there. Cosine 60 is 1/2. Cos 45, 2. Sine 60, 3/2. And sine 45, 2. Okay? And then we keep calculating there. It's 1 times root 2 is root 2 over 4 minus root 6 over 4. Can I combine my roots?
Yes.
Is root 6 or root 2 minus root 6 negative root 4? No, you can't. Remember, roots are like variables. If they're not the same, you cannot add or subtract them. Okay, you can simplify them if you can, but there's not a perfect square that go into either of those. So we could just rewrite it as root 2 minus root 6 all over 4, since they have a common denominator. That's the way we generally write that. And if you actually were to take that and put that into your calculator and calculate it out, make sure you put the numerator in parentheses if you're doing that. Okay? And then calculate what cosine 105 is. Make sure you're in degrees. You should get the exact same value. Okay? All right.
Calculators on the table.
Any questions there? All right, everyone rate themselves 1 to 5. All we're at right now. Okay, we're going to do some more practice on those today. We'll spend a couple days on them. So, next thing I want you to do, I want you to take your calculator out. I want you to set it to that window. And go ahead and complete that there. Fill in your box here. What is the value of y when theta is 45 degrees? Riley, what'd you get? 0.7. All right. Put that over here, 0.7. And what's the value of y when it's negative 45?
Negative 0.7.
Negative 0.7. How about 90? Go ahead, Brooks.
I got 1.
1. How about negative 90? Go ahead, Noah.
Negative 1.
Negative 1. Okay. So therefore, based on these findings, and we could keep going, but what can we conclude about sine of negative theta in terms of what goes right here? Yeah.
Negative.
Yeah, this is negative. So sine negative theta is equal to negative sine theta, or the opposite of sine theta. So all you're doing is flipping your sign there. All right? That is one of your negative angle identities. Okay? We're going to try the same thing now. Let you copy that down if you haven't done so. But we're going to do the same thing with cosine. I want you to now calculate the cosine values of these. Same settings on our calculator. But find the cosine values of those thetas. Or find what y equals when you take the cosine of those angles. At 45 degrees, what does y equal for cos theta? Someone that has participated yet today. Andrew, what do you got?
0.7.
0.7? Okay. Go ahead, Andrew, for negative 45.
Negative 0.7. Wait, what?
Other Andrew.
I got this, Andrew, for 45. You have
So
negative?
now I got negative 0.71. I got 0.7.
Yeah, I got just 0.7.
Positive.
Not
I
negative.
think it might be positive there.
It is positive.
Yeah. Hey, Jacob?
I got negative 0.7 for 135. And negative 0.7 for the...
Okay. So the cosine of negative theta is equal to what? What goes here? Yeah, positive. Okay. Really, what we've done there using our calculator is we have the negative angle identities. There they are. All right. I could have just shown you that. Yeah.
It's too easy.
It's true.
Much easier.
Hey, you can really think of these in terms of graphic form. You can also think of them in terms of your unit circle. If I were to look at the unit circle and I'm here, say at 30 degrees, what's my value of sine at 30 degrees?
Oh my gosh, it is 1/2.
1/2. Well, what if I go the opposite way and I do negative 30 degrees?
It is still negative 1/2.
It is now negative 1/2. So the sine of negative theta, or negative 30 in this case, is equal to the opposite of sine theta. Okay? You're showing the same thing there. And in terms of cosine, if you kind of go the same route, well, we could just use the same picture. Just use the same picture for cosine. This is root 3 over 2. Still root 3 over 2 when theta is negative.
Just root 3
Okay.
over 2.
And you could also see that if you wanted to look at it in terms of a graph. Okay, looking at your graph, if you go the other way from 0 degrees. Okay, all right. I won't make you do that. Why don't you take a look at number 6? I think is this one on your worksheet? No.
Number 8, 9, and 10 are. Unless it's on the mystery backside, no.
No. All right. We'll try that there. All right. So what we're doing here is we know if cosine A plus B equals, what does it equal again? Someone besides Riley this time. Jacob, what do you got?
Cosine A times cosine B plus sine, or no, minus sine A sine B.
Okay. All right. So Brooks, what am I doing now?
Now, at that point, from there, you are swapping in negative b instead.
Good. We're putting in negative b for b. Well done. Okay. So cos A
Minus b.
plus negative b
Oh, okay, that's going that way.
equals cos A times cos negative b. Well, what's cos negative b?
Positive b.
Yeah, it's still right. If we go back to our identities, cos negative b is equal to
Cos b.
cos b. All right. So it's still cos b minus sine A times sine negative b, and sine negative b is
Sine A. Oh, negative sine b. Negative sine.
good. Yeah, negative or sine negative b is negative sine b. Right? Which means this negative now carries out to in front here and makes that plus. Everyone see that?
Yeah.
Okay.
Riley doesn't. Riley is also a slightly white hat.
I believe Riley gets it. Okay, so this negative is going to carry out, it's going to make that plus. So the difference identity, the angle difference identity for cosine is also weird. It makes, you'd think it would be minus, and it's actually plus, and the one for angle sum identity is minus, whereas you'd think it would be plus. They're kind of backwards. Okay? So here are angle difference identities. So now we can add and subtract angles of theta.
Yay.
What's up with the little mime action you're doing?
I don't know.
I don't know either.
My hand was hurting. Stretch.
Okay, any questions there? Nick,
Wouldn't that be cosine negative b though?
No.
where at?
On the bottom.
Because cos negative b equals cos b.
It has to be checked.
Hold on. Nick, what's the question? Right, are you talking right here?
Yeah, right there. Wouldn't that be cosine negative b?
It would be. So when we plug in negative b right here, we kind of just talk through that. But there's negative b. Cosine of negative b, your negative angle identities, is the same as cos b. Remember we just worked on that? Okay. So these are the same. All right. Hey, I want you to try number 7.
Sunburn Nevin.
Oh, did it? That's 2 graphs.
You moved it down.
So they're the same graph.
Oh, you did.
So therefore they're the same. So therefore it works.
You moved it that way one
Did it? Brooks.
Yeah, it's a negative cosine.
No.
Yeah, look at it.
It's just sine shifted.
To a negative cosine.
So it's shifted downward. It's not cosine.
It is cosine. Look at it.
It is.
Dead.
It is, but it is.
Remember, isn't it shifted to a negative cosine direct? That's what it turns into.
Yeah, but it is sine, but it's just shifted to not cosine.
Yeah, you use the sign identity. But it's the cosine.
Hey, there's number 7.
Oh, it's a negative.
And we got negative cos theta. Well done. So using the angle difference,
Well, no.
right? Your two angles are theta and 90. If you think about a graph of that, if you were to take the sine curve and say we start it, let's draw the normal sine curve.
Right. Much.
Okay, you've got your sine curve. You continue it back this way. Okay, and I'm just going to go 90 degrees. That's 180 right there. So there's 90. Here's 90. If I shift this sine curve 90 degrees, which is what this is saying, that's an H shift of 90. This point right here is now shifting to right there. Okay, which means my new graph starts here, goes up, peaks there, comes back down, is there. So you now have the negative cosine graph. Okay? Negative cosine theta. Alright? Questions on it? Hopefully that's what you'd see in your graphing calculator as well. Okay. Yeah.
Okay, so we use the sine A minus B on that one, right?
Yep.
Okay, when we put in at the very end sine B, it's
Correct.
sine negative 90. But where does the second?
No, it would just be sine 90, not negative 90.
The negative goes into
Oh,
the
okay.
Yeah.
addition.
Yeah.
Silly.
It'd just be sine 90. You don't put negative 90 there.
Oh, so it's just the subtraction.
Minus.
It doesn't
Cor-
make it negative.
Correct.
Okay.
Yeah, you don't put the negative. Good question. So A is theta, B is 90. It's not negative 90. Good. Other questions? Don't do it, Brooks. Hey, don't do it.
Okay.
Takes all their distraction. Or all their attention. Makes a distraction. All right. Let's check out number 10. Last one. This one's tough. You got to persevere. Don't give up. Those of you working on your portfolio pages right now, not doing this stuff, homework's going to be a lot tougher, man.
On the homework.
If you need help, here's your hint. Tangent in terms of sine and cosine is what? Good. Sine over cosine. So that is sine negative 300 over cos negative 300. Okay? And if you think of that in terms of addition or subtraction, two angles that add or subtract to make 300. Yeah, you can go up with a bunch of them. If you try to stick with like quadrant 1, you could say 60, like sine of 60 minus 360. And cos 60 minus 360. And I use 360. 360 is an easy one to use, right? Because you get ones and zeros there. And then you can come up with a bunch of different values to find 300, but makes it a little easier when you're dealing with 360. Yeah?
Couldn't you just do sine of 90 minus 30?
Yeah. Like I said, you could do 30 minus 90. Well, 90 minus 30.
Yeah,
I'd prefer you.
60.
Yeah, you're trying to find you're finding a coterminal angle then, right?
Yeah.
Which is fine. I'm trying to use the exact values of it.
Makes sense.
Yeah.
Does it matter which values you choose in the grand scheme of things?
No. What did you use different ones?
No,
Okay.
I was just wondering.
So if I'm using sine, if I'm calling this A and B again, that's sine 60 times cos 360 minus cos 360 sine 60. Running out of room there. Okay, and let me zoom into that for us. If I do the cosine one, I get cos 60, cos 360, plus sine 60, sine 360. Okay, sine of 60 is?
Root 3 over 2.
Cosine 360?
1.
Cosine 0?
1. I was
1.
right.
Think of your unit circle. Okay. There's 1. Oh, I messed those up there, didn't I?
Just a bit.
Unbelievable. Who said probably? That's ridiculous, man. Thanks a lot.
As in,
Jacob. We're together, right? We're together.
See how it is. Okay. Cosine 60 is 1/2,
I was about to say.
and sine 360 is
Second.
0. So on the numerator, we get root 3 over 2
Minus.
minus 0, which won't matter.
root
So,
2.
and then on the denominator, cosine 60 is, it's again 1/2. Cosine 360 is 1. Sine 60 is root 3 over 2. And sine 360 is
0.
0. And so you get 1/2 on the bottom. This becomes 0 back here. Okay, that became 0 there. So you get 1/2. So you get root 3 over 2 divided by 1/2. It's the same thing as root 3 over 2 times 2, which is 2 root 2 over 2, which equals 2 root 3 over 2. Excuse me, too many 2's. 2 root 3 over 2, which is root 3.
Oh, and that was on our table chart.
Woohoo! That was on your table chart.
I still have that.
How many got it right?
That is a cheat sheet.
Nice.
Does that count?